So let me start with the background. Good. Okay. So basically, what is HIE? There are many sample HIE infrastructures that are emerging very recently. NHIN stands for Nationwide Information Network. It's as it says, it's a nationwide network that tries to consolidate all the resources in different hospitals in the states. Likewise, in each state, we have a statewide information network, GAHIN, which stands for Georgia Health Information Network. Is a similar network, but at the scale of a state. So these two projects are initiated by US government at the level of both federal government and state government. Commonwealth is a health alliance, which is formulated by big healthcare companies like Epic and, not Epic, Greenway and McKesson. To run those information network, there are some open source project that is ongoing right now, like the Direct project and the Project Connect. So those two are something that we researchers can play with. Let's take a look at the system model of each information network. We can see that in this system, it consists of two parties. One is hospital, the other is patient. Take a look at this picture. Horizontally between patient and hospitals, there is a selected trust relationship that is established. For example, patient can choose which hospital to trust by visiting those hospitals. But for the hospital that the patient does not visit, there is no trust relationship. Horizontally, between different hospitals, we don't assume any trust relationship between them. This is reasonable assumption. Let's say different hospitals are competing for the same customer base. So it's very difficult for them to establish trust relationship. So the application scenario we focus on in this work is how to find patient records which are potentially located on remote hospitals. Let's say I'm a patient, I'm checking myself in a hospital. The clerk, the front desk clerk, will need to locate my previous medical record on this hospital and other hospitals. The general workflow is that the clerk will first search for the local database and then search for the record in the remote databases. So this second step is what our research is focused on. In order to achieve this, there are multiple solutions. One baseline is simply to broadcast the search request to all hospitals in this network. Let's say the searcher will search for the record, and he sends his search request to all these 4 hospitals. Then he gets authenticated for each request, and then he can search for the local contents on each of these 4 hospitals. As the result turns out, there will be probably one hospital who actually have the data of interest. Or the 3 hospitals may not have the data. So in that sense, these 3 searches would be wasted. Okay, this is for 4 hospitals. What if there are 6,000 hospitals in the United States, which makes this solution or makes this approach impractical or unscalable, because it is very labor intensive for the clerk to get authenticated and authorized to access each of these 6,000 hospitals. Clearly, another approach is to rely on a centralized, trusted host. Let's call it EMPI host. So basically, this is how it works. Different hospitals will dedicate their local database to this host. Let the host store a copy of his original data. And then when the searcher searches the request, he will send the request to this host. This is very efficient. One search will finish all the job. And this approach is adopted by some open source software, let's say OpenEMPI, and some commercial software, let's say NextGate. But again, there is a problem in this approach, which is the trust. As we mentioned, in the private domain, different hospitals are competing with each other. So it makes it very difficult to find a centralized trust in a third-party entity. So maybe you will argue, let's use US government to host the data. But with regards to the recent US government NSA surveillance program, there is not so much public trust out there. So our approach is based on record locator service. In this approach, the raw data, the original copy of the medical records, are still located in the private domain. They are protected by owner hospitals. Only some metadata describing these records are published to the public domain hosted in RSA's host. This is a standardized procedure defined in several HIE systems. Let's take a look at the data model. So in an abstracted way, we can see the data in a matrix like this. It is essentially a mapping data from different patients to different hospitals. Here, we made the assumption that patient has a unique ID globally, which may not be the actual case. For example, if I use my SSN to log in this hospital, I may use my driver's license number to log in another hospital. But this issue is well handled by related work like privacy-preserving record linkage, which is an active research area, and the researchers from Vanderbilt University and University of Texas Dallas are doing research in this area. So our focus is on the privacy aspect of RLS data. So we assume that RLS data is private. For example, if an outsider can know that Mr. Robin Williams visited rehab some time ago, then he can probably infer something that is very sensitive and private about this actor. And also, this is an important problem because privacy preservation is regulated by several federal laws, like HIPAA. So this is the workflow of our proposed privacy-preserving RLS, or we call it PPI for short. So the search flow consists of two stages. In the first stage, the searcher would contact the PPI server in the public domain. After get some mapping data, which describes which hospital will potentially has the data of interest, then he will move into the second stage to contact each of these redirected hospitals. So now, let's say there are 2 hospitals that are redirected. And after get authenticated and authorized, he can find out, okay, only one hospital has my data of interest. The other hospitals do not have one. So the difference here is that the number, the amount of false positive of this front face is controlled. So it will not be all the hospitals in this network, so that we made a balance between privacy preservation and search efficiency. So that's for the regular searcher or a legitimate searcher. So what if the searcher is adversary? Then this is what will happen. The searcher cannot, basically, he can finish the first stage, but he cannot finish the second stage by getting himself authorized and authenticated in the private domain. So even though he can get the identity of these two hospitals, he cannot infer which out of these two are true positives. So basically, he cannot distinguish from the smiley face and the front face. By this way, we preserve privacy. So now we discover a new privacy attack, which is something like this. What if these two redirected hospitals are both reherbs? Then, no matter which hospital the patient actually visited before, the attacker can still infer something about about this patient's previous visit and his maybe medical condition. So in order to solve this problem, our idea is to group hospitals of diverse specialties together. So it's a very simple idea. Basically, in the same group, different hospitals are indistinguishable from each other. So when the search request is redirected to one hospital in one group, it will also be redirected to any other hospitals in the same group. And if we can group hospitals together, of different specialty together, then the attacker cannot infer anything sensitive about this patient. Right? So let's say if we group rehab and the cancer center and women's center together, then the searcher or the attacker cannot be 100% about the medical condition of this patient. Okay. So during the grouping process, we consider two goals. One is diversity. The other is different or differentiated sensitivity. In terms of diversity, let's take a look at the group model. So each group will have several hospitals. Each hospital is modeled by a specialty vector. Let's say one represents this hospital has the specialty in this category, and the 0 means it does not have. So a group-wise specialty vector is a merged version of hospital-wise specialty vector. So here, 1 to 0 means that in this group, there are one hospital with specialty 1, two hospitals with specialty 2, and there is no hospital with specialty 3. And we consider two metrics. One is called L-diversity. So basically, L-diversity is the number of non-zeros in this vector. So here there are two non-zero, so L-diversity is simply 2. The second metric, which is advanced one, is called group-wise entropy. And in this case, the entropy is this value. So our goal is to group a bunch of hospitals together so that in the end, different groups will have diversity value that is bigger than the user-configured one. By this way, we can achieve user-specified privacy. So in terms of sensitivity, we observe that different specialties have different levels of sensitivity. For example, rehabilitation center will be more sensitive than a hospital for ear, noses, and throat. So in our grouping algorithm, we try to make it favor the sensitive specialty over the non-sensitive ones, so that actually the search efficiency can be improved. So next, I'm going to talk about the PPI construction process. The PPI construction process is a process that takes input from different hospitals of their private data and then construct a public domain PPI data with some noises. And this process has to be made secure because different hospitals are untrusting each other. So the construction process that involves some interaction between different hospitals needs to respect the information confidentiality when they constructing the PPI. And our current protocol for index construction consists of two phases. The first phase is to group hospitals by a third-party entity in the public domain based on publicly available hospital specialty information. So for example, we can crawl the specialty information from USENIX. So basically, USENIX provides this data set, basically ranks different hospitals by their specialties with 3 grades. Like the yellow one is, the yellow one is nationally ranked. The silver one is high performing, and the dash is just say this hospital does not have the corresponding specialty. And using this data, we can cluster different hospitals into different groups with the diversity goal achieved. Okay, the second stage is just to conduct this group-wise secure computation for set union. We implement a protocol based on this crypto conference paper. By using this protocol, we can actually merge the patient list of different hospitals in one group together in a relatively efficient way. An alternative approach is just to use the generic multi-party computation, which, however, is very inefficient. So right now, this project is in the stage of implementing a prototype. We try to integrate our technique into existing open source software rather than implement everything from scratch. So Open EAPI, or Open Enterprise Master Patient Index project, is the platform we try to integrate our technique into. And in particular, we modify this component, shared health records, in this project. And although we have an open source software, we don't have any realistic data set regarding the patient visit history. So right now we are trying to get some available data and to do the simulation on this platform. So this wraps my talk. This is the references mentioned in this talk. Thank you very much.
I'm Emily Gretz with Peter and Kevin from University of Michigan. So what would happen if a group was, although unrelated focuses, if they were all things that you wouldn't want to be associated with? Like, for example, rehab or something to help with an STD. Like,
Okay.
I don't want anyone to know either one, but.
So if I understand right, the question is about clustering hospitals of totally unrelated specialties together. I think this is the case that favors privacy preservation because you cannot be sure which category the patient actually go to, right?
Well, sure, but you know that it's one of those two things. There's, you know, one of this collection of things that is full of stuff you don't want them to know.
Okay, so you are saying both.
Like if
I don't
all
want
of
them.
the options are undesirable locations, would that be something to look out for, maybe, or?
Yeah, I would say that's an advanced version of our protocol. But right now, we kind of like categorize different specialty in different levels of sensitivities. So as you mentioned, if two specialties are very sensitive, we try to mingle them with insensitive ones so that the patient
otherwise. Okay, cool. Yeah.
cannot infer anything sensitive about it. Yeah.
One more question, and we'll move on. Hi, Mike Shannon from Hopkins. Just a quick question from your set of all possible hospitals. Do you have an approximate number? Because you might imagine that there's an association between specialties such that you draw some correlations. So I don't know per se, but if I have 3 hospitals that their specialty might be X, but say they're subspecialty or they're not so subspecialty, but they still handle as Y, it might still be able to leak private information about you. Have you considered that?
Yes, that's exactly the scenario we're trying to avoid. So if every hospital in this group has specialty Y, then it depends on how many other specialties this group of hospital have. So if it's, the scenario is like, let's say we have 3 hospitals and all these 3 hospitals have specialty 1, but all the other specialties this hospital do not have, then privacy is definitely leaked. So you can be 100% sure that the patient must have health condition related to specialty 1, right?
Sure.
But if all the other specialties are there for these 3 hospitals, then you cannot be sure, okay, which specialty this patient will have their medical conditions.
Sure, but is there a bound in the amount of hospitals? So if you only have 3 hospitals, I have 1/3 chance to guess the appropriate one, which is probably enough to leak your privacy, right?
Okay, so we made this user configurable.
Okay.
If user is or system administrator is very concerned about the privacy, probably we just boils down to the very basic case where the search has to be broadcasted.
Okay.
But there is a trade-off between them, yes.
Thank you. Okay, thank you.
Thank you.